Okay, Assalamu alaikum guys. This is a video about momentum. And so momentum is a vector value. We use the letter P. P equals mv. M is the mass and v is the velocity. So what is the unit for momentum? The mass is in kilogram and the velocity is in meter per second. So this is the unit of momentum. So you need to have a mass and a velocity in order for you to have momentum. So if you are at rest, v equals 0, therefore p equals 0. It doesn't matter whether your mass is 0.1 grams or whether it is 2000 kilograms. V equals 0, p equals 0. Also, if you're massless, well, that's another story. Okay, we'll continue on momentum. Now we're going to talk about collisions. We have two types of collisions. We have elastic collisions, and we have inelastic collisions, In any collision, momentum is conserved. This is of crucial importance. In any collision, momentum is conserved. So in both collisions, whether they are elastic or inelastic, P initial needs to be equal to P final. P initial needs to be equal to P final. However, the kinetic energy that we start with in an elastic collision is greater than the kinetic energy we end up with. So there is a loss of energy due to heat, energy of sound, deformation, etc. In an elastic collision, and those are not very common, the kinetic energy initial equals the kinetic energy final. So all the kinetic energy stays the same. There is no transformation for the kinetic energy to go to sound or heat or a deformation. Now we're gonna solve a question and then we're gonna see whether it is an inelastic collision or an elastic collision. So I have here a block of mass 2 kilogram moving at v going east, maybe 4 meters per second, and then I have a block that is not moving, and let's say its mass is 1 kilogram, and then v is 0 meters per second. So what's the initial momentum here? It's going to be 2 times 4. The mass is 2 times 4 plus 1 times 0. So the total is going to be 8. Again, what's the unit? Kilogram meter per second. Then let's say that the 2 kilogram collides with the 1 kilogram and they stick. So this is before collision. And then after collision, let's say that after collision they stick to each other and form one mass. So they are so this is the 2 kilogram and this is the 1 kilogram, and we have a bulk of 3 kilograms here moving at the same speed or moving at the same velocity at v final, and we want to know what the v final value is. So the v final, so let's calculate what is, so the P initial is going to be 8 kilogram meter per second. The P final, I don't have 2 masses anymore, I have one whole mass, which is 2 plus 1, so 2 plus 1, that is 3, times v final. So I have 3 v final. Conservation of momentum, which is a very important law in physics, tells me that the P final needs to be the same as the P initial. The P initial was 8 kilogram meter second minus 1. P final is 3 times Vf. Vf is the common velocity or the common speed here. And if we're after Vf, we need to say, you know what? Momentum is conserved. Momentum is conserved. So if we write that momentum is conserved, I can say Pi equals Pf or Pf equals Pi. It doesn't really matter. It's the same thing. So I'm going to say 3 times Vf equals 8. Then if I am after the Vf, I'm going to divide both sides by 3. And then I'm going to get Vf equals 8/3 or 2.67 meter per second. So this is the V final of the system of the 2 and the 1 kilogram when they stick to each other. Now, so this is the V final. Now we remember that. We're gonna see if it is an elastic or inelastic collision. So what do we need to do to see if the collision is elastic or inelastic? First of all, we need to calculate the kinetic energy initial, okay? We also need to calculate the final kinetic energy and see if the final kinetic energy equals or is less than the initial kinetic energy. So remember the two blocks. This guy, 2 kilograms, was moving at 4 meters per second, and this 1 kilo here was not moving. So what is the kinetic energy? It's going to be half. This doesn't have any kinetic energy. Kinetic energy here is 0 because it's not moving. You know that kinetic energy is the energy that is related to motion. And then here half, 2, and then 4, we square the 4. Remember, we square the 4, it will give me a 16. The 2 and the 2 cancel out, so it's 16 joules. 16 joules. Now, let's calculate the final kinetic energy. What is the final kinetic energy? The final kinetic energy, remember the two objects, they stick together, 2 kilogram and then 1 kilogram, and then we calculated the V final to be 2.67 joules. So K final is going to be half, 2 plus 1, which is 3, and then V final squared, which is 2.67 squared. This kinetic energy, the final kinetic energy, we get approximately 10.7 joules. Now, guys, is 10.7 joules equal to 16 joules?
No.
So it is less than 16 joules. So what is the difference here? What is the delta KE? What is the delta KE? It's going to be the difference, you know, and I'm not, I don't care about the sign of this difference. It is a loss, so it should be a negative sign, but I'm just talking about the net loss. So it's going to be 16 minus 10.7. So this is what? This is 5.3 joules. 5.3 joules. These 5.3 joules of kinetic energy loss, where did they go? They went to energy of sound. You know, when they stick, they release some sound. That sound has energy of sound. Heat, you know, if you clap your hands, you know, we always use this example. If we clap our hands, we feel heat, and then there's sound. So energy of sound, heat between the two carts, and maybe deformation. Okay, so these are possible ways that the 5.3 joules were used. So now, since the final kinetic energy was less than the initial kinetic energy, is this collision elastic?
No.
Or no, it's not. Definitely not. It is inelastic. So we can conclude that, conclusion, in this example, the collision was an inelastic collision. Okay, you got it, guys, and when you got it, you got it.